Hey guys, this is Grant and I'm back again with another video. And today this is part 2 of our flux problem, and we have this integral set up, and all we need to do is evaluate it, and that's what we'll be doing today in this video. So we have flux equals this triple integral. So now our first thing is we're integrating with respect to rho, so we can forget everything that isn't rho. And that is so it's ultimately going to be rho to the fourth. So we're going to have the integral of rho to the fifth times that constant 4 and then all those other constants. And we're going from 0 to 4. So 4 to the fifth, that is 1024 times 4. That's 4,096 over 5. And then 0 to the fifth is 0. So we're just left with that. That's our constant. We can throw that out in the very front since that's just a constant. So 496 for 5. Now we have the double integral, pi over 2 pi, 2 pi, and then now we're integrating with respect to phi, so we can forget everything that isn't phi. It looks like we have sine cubed phi, d phi, and then everything else is theta, so that can be kind of forgotten about for now. So we're just integrating this right here. Cool. So if we remember sine squared phi is 1 minus cosine squared phi. So what we're going to do here is make this sine phi 1 minus cosine squared phi d phi from pi over 2 to pi. And now we can do some u substitution. That's how we're going to attack this. U equals cosine phi, and du is going to be negative sine phi d phi. All right, so now we can make our substitutions here. This is still a definite integral, but the bounds upper and lower limits are different here. So now we have du is negative that, so that's going to be du, and now we have 1 minus u squared. All right, when we integrate this, what we're going to get is, what is it going to be? Minus, and then u minus u cubed over 3, and then still a definite integral. And we'll carry the minus sign, so it's plus u cubed over 3. So, remember, all u is cosine phi. We're running out of space here. We're going to get another piece of paper. All right, so remember, so what we're left with here is minus u plus u cubed over 3. So minus u plus u cubed over 3. And yeah, just remember that u is just cosine phi, so we're at minus cosine phi plus a cosine cubed phi over 3 from pi over 2 to pi. All right, well, the cosine of phi is negative 1. The cosine of pi is negative 1, right? So that's just going to be negative 1 times, that's positive 1. Cosine of pi is negative 1. Cubed is still negative 1. Minus 1 over, so that's minus 1 over 3. And then the cosine of pi over 2, well, that's just 0 for both cases. So 0. So ultimately, this is going to be 2/3, right? So this is just another constant. Remember from our previous sheet here, we had 496. So this integral is just 2/3, so we're going to put that right there. So it's going to be 2/3 times 4,096 over 5. And then we're left with our last integral, which is pi over 2 to 2 pi of, let's see what's left, sine theta cosine theta, right? Sine theta cosine theta. And remember, we're going from pi to 2 pi d theta. All right, well, this is just a simple u sub again. U is sine theta, du is cosine theta, d theta. So this is going to be u du, and ultimately going to be just u squared over 2. So this integral is going to be, this is going to be 1/2 sine squared theta over 2 from 2 pi to pi. Okay, well, let's see, we can look at this, I guess that wouldn't be 1/2, that would be pi over 2. Okay, well the sine of 2 pi is 0, right? We know that because the sine of 0 is 0, 0 is 2 pi. And the sine of pi is also 0. So this is just going to be 0 minus 0, which is 0. So it's going to be 0 times this constant. We can call this constant k if you like. 0 times k. Well, that's still just going to be 0. And that is going to be our final answer. So we did a lot of work, but the answer is ultimately 0. And we figured it out because of the divergence theorem of Gauss. Again, divergence theorem of Gauss. And right there, divergence theorem of Gauss. And yeah, ultimately that's what we did. And we evaluated this integral, found it to be 0, so the flux is 0. Thank you guys for watching.